Okay, next question. How many three-letter words can be made from the letters A, B, C, D, E, F, G?
With this kind of question, I'm assuming they don't actually have to be real words, just how many...
Correct, yeah. So for example, okay, A, E, C would count as a word. It hasn't got to be in any dictionary.
So would it really be like an estimate of the maximum?
We are going to work out an exact value. It will be an exact value, okay? But can anybody else give me another three-letter word?
Bad.
Yeah?
ABC.
ABC.
Do you have to do like the amount beginning with A and then times that?
We could do that. We could do, if we're going to do it systematically, we will find a quick way in a minute, but we could start off like that. Is there anything else anybody wants to say about these?
I was just going to say, can the letters be repeated? Like, do you have AAA?
No, we're not going to have, we're going to use, if they're only there once, we're going to only use them once, okay? But the thing I was wondering whether anybody would pick up on, AEC and ACE and CEA will count as different words, okay? Because in words, the order does matter. So it's really important in this question to realise that here, the order matters. And when you are choosing, there's something new here as well. We are not using everything. We are choosing a subset of order up here. So the other new thing here is we are choosing a subset of values. And when these two things come together, the order matters and you are choosing a subset of values, we are talking about permutations. Okay? Yes, it does. Now let's have a look at it. I'm going to start this off using a system I said can often be useful last time. We're looking at three-letter words. Let's put down three placeholders, three dashes, three lines to hold the letter. How many letters are there that could take that first place? How many letters? I'm going to write it out in full this time, you wouldn't know. How many letters could take this place? And people have answered 7 correctly. And then, okay, same question, how many letters could take second place? Remember, we said with Jack you couldn't use the same one again. 6 is correct. And then ask the same question about third place. 5. There are 5 left. And what we do is we multiply those together. So 7 6s are 42. 42 times by 5. Yeah. Okay. There will be 210 permutations. 210 words that we could make. Yeah, it's a lot. In total, yeah. And that is a precise exact total. I'm not going to set it as a homework to work them all out, write them all down. If you were going to do it, you would do all the ones starting with A. And then, do all the ones starting with A, B, and then AC, and so on. You would find that are 210. Okay? So, given we've done that one, can we do this one that's coming up next then in a very similar way? Say this time we've got 10 letters for this new example, and we just want to choose 4 of them. So let's think of it the same way. We are choosing 4 letters. You've got your 4 placeholders. How many letters could we choose, Lucy, for the first placeholder? Yeah. And for the second one? And then 8, and then 7. And we times those together. 9 8s are 72. 72 times by 10, 720. 5,040. I'll take the word for it. I don't actually have that answer here. this 10 times 9 times 8 times 7, it's a bit like that, isn't it? But that is 10 times 9 times 8 times 7, I'm deliberately changing colour here, times 6 times 5 times 4 times 3 times 2 times 1. And that red stuff, really, I want to kill off. Go on. Yeah, because that's 10 factorial, that top line. But really, I want this to disappear. So if I put it on the bottom as well, and that is 6 factorial, what actually will happen will be that those bits there will cancel out with those bits, and I shall only be left with what I want. So this could be quickly worked out as 10 factorial over 6 factorial. So the most important one of these we're going to look at, if I had n letters and I wanted to choose r of them, what would that be?
Would you have n factorial over n minus r factorial?
Yeah, that's correct. Okay, up here, when we had 10 letters, it was 10 at the top. And then when we're choosing 4, this 6 is 10 take away 4. So yeah, that is what we have. And that is the formula for permutations. I'll take a question in 1 minute's time, okay? That's the formula for permutations, and I just want to write down some notation for that. You will find that often as a big P with the N up top left and the little r bottom right, and that you'll find on the calculator. I'm just going to pause the video at that point.